Good evening, folks. Tonight's video is going to be a little sort of project build, and what we're going to be doing is basically modifying a Raspberry Pi power supply. Now, the Raspberry Pi, I'm sure you're aware, is a little single board computer, very versatile, and I use them for lots of various projects. In this enclosure here, we've got a Model B+. I've also got a Model 3, but this project will work for absolutely any of the Raspberry Pi variants. Yeah, really good little computers. If you've not got one, just buy one. They're really cheap. And I think at the time of making this video, it's the most popular British computer ever manufactured in terms of the number of units sold. And of course, you'll see projects using the Raspberry Pi absolutely everywhere. But yeah, when you're using them, there's no actual physical power switch on them. And to power them down or power them up, you have to either insert or, take out the USB power supply or switch it off at the mains. Now, if your power supply isn't very accessible, it will mean that you do have to physically disconnect the power supply. And of course, these are actually very well made computers, but we want to sort of minimise the wear and tear on the socket. And of course, if if we are putting it in and out quite regularly, we do run the risk of weakening the joints on this surface mount socket, and potentially that could detach from the board. So the little project and modification we're going to do tonight is basically taking a power supply and making it to have an inline switch. And I'm not going to modify this one. This is the official Raspberry Pi power supply that comes with the Model 3. We can see 5.1 volts at 2.5 amps. No, I'm going to use, another power supply, one I had lying around in the workshop, and we're going to modify that for this purpose. Now, just before I started recording this video, I did go on eBay, and you can buy a 2 or 3 amp micro USB power supply from eBay for £2.35, including delivery to the United Kingdom. And I do talk about cheap electronics and how it's perfectly acceptable to use cheap electronics, but if you're going to be using your Raspberry Pi regularly and thinking about the ancillary items that you may have connected to it, such as a Wi-Fi adapter, maybe a memory stick, keyboard, mouse, TV dongle if you're using it for a software defined radio, something like that, even a portable hard drive, I would certainly not recommend using a cheap power supply, because you want to look after your kit and obviously look after the kit that's attached to the Raspberry Pi. So what I had knocking around in the workshop was this 2-wire power supply, and 2-wire will manufacture data communications equipment. This came with a router. I think it was a BT router, and I bought a job lot of routers for, I think I got about £8 including delivery, and there was about 4 or 5 routers, and they all were the same, these 2-wire ones, and they came with these fairly decent power supplies, and that was basically the main reason I purchased them. But as we can see, this is 5.1 volts at 3 amps, and of course we can go, it's a slightly higher current rating on this, but that's not going to cause us any problems, because the Raspberry Pi will draw what it needs to draw, as long as the voltage is within or between 4.75 and 5.25 volts. It will power it just fine. The Raspberry Pi Model 3 does suggest that a 2.5 amp power supply is better, because it's more power hungry, I suppose is the term. So this is going to be ideal for a little project. So what else are we going to be using other than the power supply itself? Well, I've got one of these things, and this was sold on eBay. I paid 6p for this, including first class delivery. Unbelievable. And I've already loosened the screws, but it's just a sort of generic inline inline switch that you probably find on like a desk lamp or something similar. But it's ideal for the project we're going to do tonight. Let's say, and for 6p, obviously a billy bargain. Clearly, you know, if you're buying this and I buy it now, you might have to pay like, I don't know, 50p or something like that. But this is going to be perfect. And last but not least, we're going to be utilising a small shell type micro USB plug, and it's just basically the plug itself with 2 halves of the casing for it. So without further ado, we'll get crack on and get building it. So as you can see, I've never actually had this open yet, but we've got around 1.5 meters of cable, which is more than enough. And what I'm going to do is just get a standard DC jack on the end. I'm just going to cut this off, and I'll cut it below this label because obviously we might have a bit of hassle getting the adhesive off. There we go. Right, so inside is not what I expected. I thought we would have had just a single insulated conductor in the middle and a sort of shielding round the side, so clearly that's not the case. So what we'll do is we'll just trim that back a little bit, and we'll just use the multimeter to see where our 5 volt is and where our ground is. Okay, dokes. So I'll just twist those up. Sorry, that might have been off camera there. So we'll just plug this in and see what it gives us. Now, I can't seem to find the plug. I don't know if there's any reason why that's got the second insulated conductor in there, but we shall get the meter on it and see what it says. So my initial thinking is it's probably going to be the red and possibly that. No, so yeah, red and green. So red's a positive and green is negative. As you can see on the meter, 5.3 volts. Now of course this power supply doesn't have a load on it, and you know, I'm more than happy that 5.3 volts with no load on it is going to fall within the 4.75 to 5.25 volts once it's connected up to the Raspberry Pi, and you know, and got a bit of load on it. So we've got that sorted out, so we now know what's what. And the next thing we're going to do is will be to put the inline switch on, and this is where it's going to be a bit tricky. Now I'll just cut that off there just now. Yeah, so what we're going to have to do is actually cut into the insulation here without hopefully damaging the conductors inside. So I'm just gently gonna cut that insulation off, not going too deep because I don't want to cut through and then we'll have to start off, and if we keep doing that, by the time we get to the end we'll have about 6 inches of cable, which isn't ideal. Okay, there we have it. So almost through. And there we go. Right, so we'll just use this as a guide. We can take quite a bit off there. If I just gently cut around that now and give us a clean edge now. It'll look a bit tidier once it's all inside. So there's no real requirement to have this copper shielding in here at this point. Can we get away with using it? I think, well, we might as well just leave it on there. But what we'll do here is we'll cut the, dead in the centre, we'll cut the 5 volt cable, if you want to call it that. We'll cut it dead in the middle, and then just spread the two ends out. And utilising our cable strippers, we'll just take the end off, like so. Okay, so that's our 5-volt lead trimmed and ready to be tinned up. So just get the old iron on the go, and we'll tin these up. Like so. And of course we need to do the actual switch itself. Now I might be teaching you to suck eggs here, but clearly the switch has got a plastic body, so we don't want to put lots of heat on here for an extended length of time, just enough to tin up the connector, and that will do just fine. Could do with my helping hands here, but never mind. Okay, so that's our switch tinned up, and then it's just going to be a case of soldering on. And again, just the minimum amount of heat to get that on. Like so. And the same on the other side. Yeah, it might need a bit more on there actually. Now of course you can buy off the shelf pre-switched power supplies, but you know, this is a really cheap mod yourself to do. There we go. So as you can see there, it's worked out fairly well. You know, there's not any great stress being put on that, and the actual negative side is taking up the, it's giving it almost a bit of strain relief, if you like. So the next thing to do will be to mount it in the case, whatever you want to call it. So we'll just put in one side just now, like so, and if we look there, that actually fits in fairly well. Now we could insulate this side here, but the worst case scenario is that copper, if it for any it's highly unlikely that it's going to move, but if for any unlikely reason that would move over and short that, the worst thing that's going to happen is your Raspberry Pi is going to turn on. So I'm not concerned with insulating that. I'm reasonably content that it's going to stay where it is. So just to offer a small bit of strain relief, I suppose, we'll just stick on a cable tie, and this should fit in there fairly well. In fact, I think we'll probably just put it on the inside here. It does have an element of strain relief built in. We'll just put it on and see if that's actually even going to be required. And you know what? No, I'm content with that. That looks fine. That's going to be perfect. So we will get our screwdriver and just pop the two screws in. like so, and that's our inline switch. Neat and tidy. So on to the actual what do you call it, connector itself now. Now we need to have a quick look around this and to see how it fits together. So that's the square side. We've got a flat side, or the square side, and that just pops in there like so. So in terms of cable length, we don't want a lot. It's really going to be the bare minimum required. So what I'll do is I'll just trim the ends off, and these will be very, very short. And I'll just use the knife, hopefully you can see that, just to trim that insulation off, give us somewhere to tin up. There we go. So very, very little indeed required. And we'll tin them up now. So that they're ready to go. So that's them tinned. Happy days. Right, now the micro USB connector. This is the internal sort of, part. Now, from left to right, as you see it on screen, so we've got the rounded part of the plug on top, you know, with the chamfered corners, and left to right on here is pin 1, 2 and 3. Pin 1 is plus 5 volts, and pin 3 is our ground. So all we need to do with that, or to make this a bit easier to solder on, is just using a sharp knife. We take the middle pin, pin 2, and if we just gently put our knife underneath that, because all we're interested in here is power, and because the cables or the conductors are actually quite thick on that other cable, I don't want to run the risk of shorting. You know, the fact that that middle pin was there, I don't want to use or keep that there as a potential short. So I've just broken that off. So the next thing to do will obviously be to tin up the connector itself. It should be fairly straightforward. Like so, and like so. And remembering that positive is on the left, negative on. Hello folks, welcome back. Right, that's the first time I've ever had to sort of stop and really struggle to do something. Yeah, this was a real nightmare to solder these on. It seems fairly solid now, so yeah, as you can see, we've got pins. I think I said 1, 2 and 3 before. It's not, it's 1, 3 and 5. But pin 1, let's say, is positive, and the last pin is the negative. So that's a fairly solid joint now. So what we're going to do now is just put it into the housing now. If we look at the two halves of the actual shell, we can see the one with the legs on it has got the rounded edges, if you want to call it that. So I think what we'll do first is we'll put the square edge in first, because it's fairly straightforward and fairly close fitting, so it's going to locate it quite nicely in the bottom half of the shell, like so. Okay, so that's not too bad. And what I think I'll do is, I've got the old hot glue gun warming up, so I'll just put a little, not a lot, a little dab in the bottom there, and that's just going to give it a little bit of sort of structural support, if you want to call it that. And there we have it, so that's not too bad looking. And we'll just do the same on the top. So I think what we'll do is, if we just actually put it there on top of the solder joints, and then the two halves simply clip over like so. And there we have it. So that's our connector on. Let's see, a bit of hot snot in there just to add a little bit of extra support and a little bit of strain relief as well, because once that sets, you know, it should be nice and strong. So we'll clear the bench off and have a look at what we've done. So we've taken this 5.1 volt 3 amp power supply. We've put a inline power switch in the middle. I've got the old cobwebs off the hot glue, and we've put a micro USB connector on the end. Fairly tidy job. Apologies for it being a little bit tricky. I would definitely recommend buying a few connectors, because I think I must have broke about 2 or 3 of them using it, and that's just because they're cheap connectors. But when you're getting a bag of, I think it's 50 or 100 I got for just over £1.50 including delivery, you know, you can afford to waste a few. So the big question is, does it work? So we shall plug the power supply in, and if I take the top cover off our Raspberry Pi and plug in our plug, and of course the LEDs are just down under these 2 little holes here. So let's see if it works. And there we go. Yeah, flashing away. And if we need to turn it off, just flick the switch. Need to turn it on, flick it the other way, and so on and so forth. No wear and tear on the socket itself, and it's, you know, it's a nice little neat, project, you know, for having your Raspberry Pi set up permanently. One sort of little point before I finish the video. This cable is fairly hefty, and I think that's basically the reason I had such problems soldering it onto the tiny little tabs on the micro USB connector. If you're going to buy or you have you know, a 5 volt 2.5 or 3 amp power supply, or you've got several of them, I would definitely recommend going for one with a thinner lead. You know, it's unlikely that your Raspberry Pi is ever really going to draw anywhere near 3 amps. But, you know, if you can get one with a thinner lead, it's going to make the job a lot easier when it comes to soldering that connector. Anyway, guys, I hope you enjoyed that. I found it useful. Apologies for it being a bit long and a bit, you know, that cut in the middle, but it was taking me ages to get that on camera, the amount of times I did it. But it is a relatively simple mod. So if you did enjoy it, as always, please give me the thumbs up. If you would be so kind, please subscribe as well. My subscribers are creeping up now, which is really encouraging to see, and I think I'm up to, I don't know how many views. I think I've got about 45 days worth of views in the last 28 days, which is really impressive. But yeah, so please subscribe if you don't mind, and until next time, take care of yourselves, and we'll see you soon. All the best.